Okay, On-Time Airlines assigns a lowercase 6-letter record locator. So in the two that they show you, we are allowed to repeat, right? Because there are 3 F's. And order matters, right? So the first little thing to do is something hopefully we're familiar with. We're making 6 choices, each one of which is from the 26-letter alphabet.
Yes.
So 26 times 26, ... There are 26 to the 6th possible locators. All right, and the question is, how long can they go before running out? Okay, and 100 million is how many they use up each year. So of these, they use 10 to the 8th. Okay, and of course we've talked about these exact numbers. So if you need to pause and figure out why 100 million is 10 to the 8th, please do so. So we need to know 10 to the 8th is, we need the number so that, let's write it like this. If n times 10 to the 8th is, if n is such that it is bigger than 26 to the 6th, but the next one down is smaller. Mm-hmm. I'm saying this poorly, but you know, you'll get it. But it's the first. Okay, to illustrate this better, I'm going to skip to the answer. We're going to end up showing that 26 to the 6th is about 3.6 times 10 to the 8th. Okay, so this means 4 times 10 to the 8th is bigger. 3 times 10 to the 8th is smaller. So there you go. There's our 3 years.
Okay.
Okay? All right. So let's go through the actual approximation, just like I did on the page. I'm going to do it very fast in the video because it's the sort of thing you can do with a paper and pencil once I just show you the numbers. Okay. So we want to write 26 to the 6th using simpler numbers.
Okay.
And the first suggestion I said was, let's trade 26 to the 6th for 27 to the 6th. The reason why is 27 to the 6th is 3 to the 18th. Is 9 to the 9th. Is 9 squared to the 4 times 9 is 81 to the 4. Now I'm used to this. This is an approximation that I've done. I've sort of almost have this memorized in that you can trade powers of 3 for powers of 2.
Okay.
Because 81 is pretty close to 80. So this first time we made it bigger.
So now we have to make it smaller.
Right. I mean, we don't have to because we're still approximating, but we know that this is good, actually, to make it smaller.
Yeah.
In the middle of our approximation. So we're going to say now, we're going to make it smaller, say 80 to the 4th times 9, which is equal to 8 to the 4th times 10 to the 4th times 9.
Okay.
Right, which is equal to 2 to the 12th times 10 to the 4th times 9. Okay.
Okay.
Another thing to have memorized is that 2 to the 10th equals 1024, which is about 10 to the 3rd.
Okay.
Right? So this whole thing right here is about 2 squared. I'm going to bring the 9 over. Times 9 times 10 to the 3rd times 10 to the 4th.
Okay.
Okay, which is actually equal to 36 times 10 to the 7th, which, as promised, is 3.8. Oh, 3.8. What am I talking about?
3.6.
I'm ahead of myself. 3.6 times 10 to the 8th. Okay, that is still pretty long to do in like 45 seconds if you're trying to do this in a super fast math contest way. But, so I don't know, maybe there's a better way. Maybe there's like a slick observation you can make where it's like, oh, it's this, this, and this, and it's 3. You know?
You could use your calculator to be helpful.
But these tricks that I'm showing you, trading a hard number for a simple power of 3, and then going from a power of 3 to a power of 2, and using this fact to kind of anchor your knowledge of estimating powers of 2, is a good thing. All right, now for the sophisticated, fancy way. Okay, the idea here in the sophisticated, fancy way is that 26 to the 6th is the same as x plus 1 to the 6th
Okay.
when x is 25.
Okay.
Okay? And we can use Pascal's triangle to expand x plus 1 to the 6th. Okay? But the first thing we have to do is we have to know the powers of 25.
Oh, wow. I know
Right.
1 and 2.
Well, let's see here. We need to know 25 to the 6th. Well, we know that it's 25 squared to the 3, which is 625
To the 3rd.
to the 3rd. Okay? Now, 625 to the 3rd, 625 is 6 plus 1/4.
Okay.
In other words, it's 25 fourths. Right?
Yeah.
Okay. So this thing right here is 25 fourths to the 3rd,
Okay.
which is, what's 4 to the 3rd?
4 to the 3rd is 64.
64. Do I agree with you? Yes. Okay. So 625 times 25 over 64. Okay, now look at this. We hit a lucky little jackpot here. 625 over 64 is like pretty close to 10.
Yeah.
Right? Okay. So,
It's only 15 off.
what?
It's only 15 off.
Oh, I'm sorry. When I said 625 is 25 over 4, I was lying to you completely. Because 6.25, so I was doing something in my head and not announcing it. So if you're watching the video and you're like, what is he doing there? Then you're the smart one. Here, I wanted to write 625 as 6.25 times 10 to the 3rd. 10 squared, sorry.
Oh, so you're just getting rid of the decimal.
Yes. Okay. But then I'm going to say 6.25 is 25 over 4. And then here I have a 10 to the 6th. So I'm carrying on a 10 to the 6th.
Okay.
Okay. Now, 625 over 64. We could just multiply out 625 times 25. I actually know it's 3125 times 5.
30
Well, 5 times 625 is 3125.
Okay.
Okay. So 3125 times 5 is 15625.
Okay.
Okay. So,
Very interesting.
but like I said, this thing right here, 625 over 64 is about 9.4.
Okay.
Okay, where do I get that from? 640 over 64 would be 10.
Yeah.
Right? So this is 35. This is 9 and 35. Sorry. This is 9 and what's 39 less than 64? 25.
Okay. Wait. Okay, yeah.
So this would be 40 over 64. Here, this is what I'm doing. I'm saying this is 640 over 64. 640 minus what amount?
640 minus
15.
15
Right?
is
Okay, sorry, I messed up. All right. 15. So this is going to be 10 minus 15 over 64. See, look, it's so easy for me to get lost. I'm just going to back up. All right? We said 625 cubed is the same as 25 over 4 cubed times 10 cubed. Okay? Because we said this was 6.25 times 10 squared. I'm sorry, this is 10 to the 6th. Times. I'm actually better at this in my head than I am writing it down.
Oh wow.
Like, so that's why I'm messing all this stuff up. Okay, now 25 cubed, 625 over 64 times 25,
Okay.
right? Times 10 to the 6th.
Okay.
Okay. Now we said 625 over 64 is 15/64ths less than 10.
Okay.
Okay, so this is like 10 minus 15/64ths. Right? Okay. Let's call this 10 minus 15/64ths. If it was 10 minus 16/64ths, it would be 9.75.
Okay.
Right?
Yeah.
Okay. So let's call this 9.8. 9.8 times 2.5 times 10 to the 7th.
Okay.
Okay. In other words, let's call it about 2.5 times 10 to the 8th. Okay. Now the issue is x to the 6th plus 6x to the 5th plus stuff.
Stuff.
Right? We have to figure out how big this is when we add it to 2.5 times 10 to the 8th. And the reason why is because, remember, we're saying that x plus 1 to the 6th is 26 to the 6th is 25 plus 1 to the 6th. We just figured out what 25 to the 6th was.
Okay.
Okay? Now, 25 to the 5th, how big is that going to be? It's essentially the same exact process, except we have to divide this answer by 25 and then multiply it by 6.
Okay.
Okay? So it is 2.5 over 25 times 6 times 10 to the 8th, which is 6 times 0.25 times 10 to the 8th, which is 1.5 times 10 to the 8th.
Okay.
Did we do that right?
No, we didn't do it right. We could only go 1 year.
What?
We could only go 1 year. We did not do something right there.
What do you mean? Oh, this is 0.1. Sorry. No, that's wrong. I messed up. This, I'll show you where I messed up. This part right here, this right here is 0.1. So this is 0.6 times 10 to the 8th. Anyway, the point is, if I add 0.6 times 10 to the 8th plus 2.5 times 10 to the 8th, I get 3.1 times 10 to the 8th. And then you can show the rest of the terms in the expansion are too small to matter.
Okay.
Okay? So in other words, what I'm doing is I'm saying x plus 1 to the 6th is x to the 6th plus 6x to the 5th plus junk. Okay? The rest of the terms are too small
Okay.
to contribute that much. All right? So we're saying 25 to the 6th plus 6 times 25 to the 5th. This turns out to be 3.1 times 10 to the 8th. Okay, neither way is very good,
Okay.
but we can live with it. All right, enough already. Let's do a different problem. All right.